Okay, so in this video, we're going to look at different properties of the EM spectrum, the different types of radiation in the spectrum. We're going to think about all 7 and think about what they're produced by, what their effects are, what their uses are, and what their risks or dangers are. Now, this is framed from the Edexcel GCSE physics syllabus, but physics is physics. It works for any GCSE or just any physics in general, but it is specific in terms of what they want you to know to that topic, to that exam board even. So we're going to start by what these waves are produced by. Now this is quite tricky, we're just going to mention them here and there'll be other videos that go into this in more detail, but across all of these 4 strands we'll see where there's similarities between the radiations that are near each other on the scale. Remember that radio waves to gamma rays, the only difference between these is the frequency and the wavelength of the wave, and that gives them different properties. And remember that wavelength is increasing this way, so radio waves got the longest wavelength, and frequency is increasing this way, so gamma rays have got the highest frequency, and they're also therefore also the highest energy. So radio waves and microwaves are both produced in the same manner generally. There are kind of exceptions. Microwaves can be produced in slightly different ways as well, but the ones we need to know about are that they are produced by oscillations in electric circuits. So if I've got an AC, that's an alternating current in a circuit, I'll be producing radio waves and microwaves from that circuit. So both of these are produced that way. Infrared radiation is produced via atomic vibrations. So you might think back to year 7 or 8, if you acted out being a solid, a liquid and a gas. A solid that's cold, the particles are quite still, so you'd stay still, but as you heat up a solid, the particles start to vibrate in their positions, and as they vibrate, they release infrared radiation, and the more they vibrate, the hotter they are, the more infrared they give out. Visible light and UV, and to an extent infrared, and also to an extent X-rays when you kind of get onto A level, but mainly these 2. These are produced when electrons fall down an energy level in the atom. So in GCSE chemistry, you'll be learning that electrons exist in different energy levels. If an electron falls down to a lower energy level, it will release a photon. Look at my previous video for that. A photon of light, and that will be either visible light or ultraviolet light, sometimes in X-ray, sometimes infrared, but usually in these 2. So if X-rays aren't produced this way, which is the least common way, if we want to make X-rays, the way we do it is that we have high energy electrons and we make them collide with a metal. So if you whack an electron into a metal, it will produce an X-ray, and that's how they do it in X-ray machines. And finally, gamma rays, these are emitted naturally from atoms that are unstable. So gamma rays are emitted from unstable nuclei. And I'm going to write in a bracket radioactivity. So if you've studied radioactivity yet, or radioactive decay, you'll have come across gamma rays there. It's the same thing, and they are emitted from an unstable nuclei to try and calm that nucleus down and release some excess energy. Okay, so that's how they're produced in a nutshell, not in much detail, but none of this is going to be in much detail. Next we have the effects. Now, just like we can produce radio waves and microwaves by having oscillations in electrical circuits, that's an actual other effect as well. So if you've got a circuit in a radio wave, it will produce an oscillation. So microwaves and radio waves also cause oscillations in electric circuits. And that's all that radio waves do, and then we then use that to transmit radio signals for radio channels. But microwaves do something else. You use a microwave not every day, I use it every day, but you might not, to heat food up. So microwaves, like infrared, because infrared is all about hot things, both cause heating. That's the effect of infrared and microwaves, and it's the main effect of infrared. Visible light, generally here we say it causes chemical changes, and there's one main one that you can think about here. Think about where light causes a chemical change. It happens in leaves, and that is photosynthesis. Otherwise it doesn't cause a lot. It causes our eyes to see, which is quite useful. But that's the main kind of effect, I would say, there, caused by that. And then finally, these last three, UV, X-rays and gamma rays, they're all high energy and they have a high frequency, and that causes them to be ionizing. So these three are ionizing. It means they can knock an electron out of an atom. And we'll come on to that more in a further video when we look at ionizing radiation. So, more commonly, you'll be asked about the uses and the risks or dangers of these EM radiations, and you should have a good knowledge of these and know examples for each one. So I'm going to start off with uses, and for uses, we're going to think about what kind of like broadly each of these are used for and how they link together. So to start with, all three of radio waves, microwaves and infrared, they are all used for communication purposes. In different ways, but they're definitely all used for communication. Radio waves are used for radio and TV, or radio signals. You can send, for example, radar. You could use a walkie-talkie, that uses radio waves. Microwaves are also used for TV, but also used for satellites, as are radio waves. I'm going to put that down here, so satellite communication. And infrared is used for internet at times. We'll come on to that in a moment. So radio waves are used to broadcast TV signals. So I'm going to write broadcast here, and it's generally we use them to broadcast terrestrial signals. To an extent, microwaves are used for that as well. We use microwaves to broadcast for satellite channels, but generally we think about broadcasting as a radio wave property, so that's TV and radio. So microwaves, we already have that they're used for communication and for satellite. The word microwave, we generally think about the microwave oven. So actually cooking is a massive part of microwaves, and it's also a massive part of infrared. So think about anything that uses heat to cook. So for microwaves, it's a microwave, but for infrared, a grill, an oven, a toaster, anything that glows red, a hob, when it gets hot, is using infrared for cooking. Infrared also is used for thermal imaging. So if you've ever seen heat images of people like night vision, that's infrared. And also for remote controls. Not all of them nowadays. Some of them are using your wireless or your Bluetooth. But a normal bog standard remote control, I happen to have one here, this is uses infrared. However, things like an Alexa remote control, and sorry, this is not an Alexa, this is a Prime, Amazon Prime one, these don't use infrared, and that's why you have to point this type of remote control at the TV to work, but this type of remote control, you can point it anywhere and it will still work because it's not using infrared. Finally, as I mentioned before, that infrared is used for internet, and it is. If you have fibre optic internet, you are probably using infrared there, and it's super fast. It's faster than normal internet. But fibre optics can also be used from visible light. So you might have a fibre optic Christmas tree or a fibre optic lamp for decoration. But also if you've ever had an endoscopy, which is where a surgeon or a doctor looks down your throat or to see into your stomach, that uses a fibre optic. Or if you have keyhole surgery and they look into your body using fibre optics there as well. People often find what visible light's uses are quite tricky. It's the big one's really obvious, hopefully, vision. Okay, so we use visible light to see, but also we need to use it for photography and also for illumination. So if you've got, a dark room, you want to not make it dark anymore, you use a light, and that uses visible light so we can see. Okay, so moving on to these more dangerous ones, but they still have good uses. UV, X-rays and gamma rays still have really important uses. Now, UV is used in a variety of ways. It can be used for security marking, or for detecting forgeries for banknotes. So detecting forged banknotes. So security marking, you might have one of the security pens that you can't see, it's invisible. You write like your address or your postcode on valuable items with it, and then if it's stolen and the police find it, they can use a UV lamp to look and see who it belongs to. Banknotes have all got a little UV kind of like a symbol that can only be seen under a UV light if they're not forged. Fluorescent lights. So if you've ever had like a disco, I can't spell this very well, fluorescent, or been on a ride in a theme park where everything that you're wearing that's white seems to glow in the dark, that's because of fluorescence, and that's caused by UV lights. Tanning is a use of UV. If you've ever seen a tanning bed, they seem to be quite purple. That's the bit of light it's emitting that isn't UV, that's the violet light it's emitting. But the UV is what causes you to tan. And we can also use it to disinfect things and disinfect water, for example. At my school we have hand dryers that have some UV light in them to try and disinfect you some more as you dry your hands. Now, X-rays and gamma rays are both used a lot in the medical world, and they're both used for medical scans. Now, for X-rays, that medical scan is an X-ray. For gamma rays, it can be anything from a PET scan to a gamma ray camera, stuff like that. X-rays are also used for airport security as an X-ray machine. And they can also be used to probe the internal structure of matter. Now, an example of this is something called crystallography, where we can see how solids are made up. But a really famous example of when we used X-rays to work out what it looked like is when they discovered the double helix in DNA. That used X-ray crystallography to work out the shape of DNA, so we can't see it with our eyes. Gamma rays are also used a lot more medically. Now, they're used to sterilise food and also surgical instruments. So instead of just washing them, they're actually irradiated with gamma rays to kill any bacteria, because all three of these, like disinfecting water, sterilising food, can kill bacteria. And also gamma rays, they are used to detect and also treat cancer. So if you ever heard of someone going through radiotherapy, they're using radiation, they're using gamma rays to try and treat that cancer. It's different to chemotherapy, because chemotherapy uses the chemicals. Okay, so risks and dangers. There are risks and dangers to all of these, except for radio waves. Okay, so currently there are none found for radio waves. They just have too little energy. Microwaves have got a very small risk of internal heating. Now think about, when you put a potato into a microwave, what does it do? It cooks, and that's because the potato's got water in it. Anything that's got fat in it as well will cook quite well in a microwave. So if you put yourself in a microwave, you would also cook. So that's the difficulty, is internal heating. It's why when people first started using mobile phones, they were worried about children using them, because they were worried about maybe cooking their brains. There is no evidence that that is the case yet, but there we are. The microwaves that are used for 3G, 4G, 5G networks, they're generally more like radio waves, and therefore they're not found to be dangerous. Infrared is heat, things that are hot, a fire, a grill, and they can cause skin burns. If you touch something that's hot, it can cause a skin burn. Visible light, generally quite harmless, except if you look at something very bright, it can cause eye damage. So you shouldn't look at the sun directly, because it could cause eye damage, and that can also lead into UV. UV light from the sun and other sources can also cause eye damage. UV though is most kind of well known for causing sunburn, and that can lead to skin cancer, and that brings us to all three here. Okay, so these three ionising radiations, because they're ionising, they can lead to mutation in cells or damage, mutation in DNA or damage to cells, which can lead to cancer. It doesn't have to, but it can lead to cancer. It's very rare for UV, although it can lead to skin cancer. It's more common for X-rays and gamma rays. So you can see the danger kind of increases as you go along the row, and that's because you're increasing the energy of the rays. So it's really important to know, especially the uses and the dangers of these types of radiation. But for EdXL, you do need to know the production methods and the effects of them as well. Hopefully that was helpful.